Hello and welcome once again to my YouTube channel. So till now we have discussed about the season trees, numerical problem of the season tree, random forest. We have solved the problem of creating the random forest also. So now let's do the last topic related to this. That is, there should be no confusion between the season tree and random trees. So this video is based on the difference between the season trees and random forest. So we know that when to use the random forest. So we know that random forest takes less time as compared to other algorithms, which predicts the output with high accuracy even if we are having the large data sets. It runs efficiently. But it can also maintain the accuracy when a large portion of data is missing. So if we have small chunks of data, small amount of data, and the information is complete, that is we are not having many missing values, then in that case we use decision trees. But if we have so many missing values and we may want to maintain the accuracy, then random forest is used, which will maintain the accuracy when a large proportion of the data is missing. Random forest basically predicts the output with high accuracy as compared to decision trees. So random forest is capable of performing both classification and regression. Decision trees also possibly do classification and regression. Random forest is capable of handling large data set with dimensionality and also enhances the accuracy and prevents the problem of overfitting, which occurs in the case of decision trees. But it has disadvantage also, that is the random forest can be used for both classification and regression. It is not most suitable for the regression task. It can be used but not much suitable. So when we talk of a decision tree, we know that they suffer from the problem of overfitting, which is not allowed to grow without any control. But on the other hand, random forest can be created from the subsets of the data, and the final output is based on the average or majority ranking, and hence the problems of overfitting are taken care of. A single decision in is faster in computation, whereas in random forest it is slower in that case. Also, when a dataset with features is taken as input by decision tree, it will formulate some set of rules to do the prediction. Whereas random forest randomly selects the observations, builds the decision tree, and the average result is taken. It doesn't use any set of formulas. A decision tree support tool that uses a tree-like graph or structure or model of decisions and their possible consequences, including chances, event outcome, resource cost, and utility. Whereas random forest is an ensemble learning method that operates by constructing a multitude of decision trees at training time and outputting the class depending on the individual trees. The problem of the overfitting that occurs in the season tree is resolved by using random forest. The results are more accurate in case of random forest, but the decision trees are simpler and easier to understand and interpret also for visualization. But the random forests are comparatively complex because it consists of more than two decision trees inside a random forest. Just like we call a forest, but we call a forest in general terminology, or a jungle, a forest in which more than one tree is present, we call it forest. Similarly, the term of random forest is came into existence, that is a forest which consists of more than one decision tree. But the factor random here means randomized sampling. So how do we work in random forest? In random forest, we create multiple decision trees with random sampling. We have only one data set. From that one data set, we create n number of data sets by using the bootstrapping process that we have discussed in the previous video. And in that case, we create the decision trees, and that collection of all those decision trees known as random forest. So I hope all of your doubts about random forest and decision trees are clear now. So if still you have any doubt, then you can write in the comment box. So thanks for watching the video.